equations of circles and how to convert them from the general form, which is sort of out of order, to the standard form. And one way we do that is we have to understand how to complete the square, and there's a video I made for that you can check out. Let's take an example and talk about one of the things we need to do. So when we look at the general form, it's over here, and the general form is neatly packed up with perfect squares. X minus 2 squared, y plus 1 squared equals 9. So from here we learned to take the opposite sign, positive 2, negative 1, opposite of positive 1 is negative 1. For the center, and the radius is the square root of the number at the end. Square root of 9 is going to be 3. Now, a few things we want to notice and then apply those things. We have the radius by itself, the whole numbers, and the x is in a perfect square and the y is in a perfect square, and they're separated by a plus sign. So that is the model we want to use. In order to do that, like we just mentioned, we remember here the whole number needs to go to the right side. So we're going to add 12 to both sides of the equal sign. And I'm going to slightly separate the x's and the y's. Now, we can have this out of order. I mean, we can have y squared here instead of here. So sometimes they'll jumble it all up. And this problem already has the x's next to each other and the y's next to each other. And I just noticed that this should be a y. So let's take a look at this equation and practice writing it in standard form. So we'll have x squared plus 6x, and we want to turn this into a perfect square. We have y squared minus 4y, and then we have equals 12. I've created some space because in these spots, when we make our complete square, to have that perfect square that's going to go down here, we have a number that's really being added because right now it's not there. So by putting that perfect square there, we're going to have to add something to both sides. And if you check out the complete the square video, I do one example at the end. So it might be a good review for you if you haven't done complete the square in a while. So I do my completing the square a little bit differently. I do the completed square, then I go back and add to both sides. So what we learn to complete the square is we take half of this number, the middle number with the x. So doing so will give us x plus half of that, 3 squared. So that's going to be my perfect complete square, and I don't need to do anything else to it. However, really quickly, if I look at what that means, it means x plus 3 times x plus 3. So we learned that that's going to be x squared plus 6x plus 9. We distribute x times x. X times 3 is 3x. 3 times x is 3x. So 2 of the 3x's become 6x. And then 3 times 3 is 9. In looking at this, something we didn't have before was the number 9. We had the x squared here, here, and here. We had the 6 here and here. So that number 9, by putting the perfect square here, is really being added to the problem. So I'm going to put it right here. And we really don't need to put it there because our perfect square is done, but it's a reminder because I added 9 there. I need to do it to the other side. Now, to recap, first thing I did is I got half of this term and put it here. Now to get the 9, I have 3 squared, so I really can just look right here. 3 squared is 9, so I do it to the other side as well. So that's the process I use, and it's the same idea, it's just done in a slightly different order. So I'll use green for the y squared. I know it's going to be y, and then half of this number. Half of negative 4 is negative 2. This works out to give us 2 squared being added to this side. So we're going to add 4, the 2 squared here, and we add it to the other side. So the next step is just to add these together. It's going to be 21 plus 4 is 25. And we need to remember that there is a plus sign in between them. So we've gotten our standard form. X plus 3 squared plus y minus 2 squared equals 25. Taking a look at that, what we have is the standard equation of a circle. And the standard equation of a circle is going to find the center at the opposite of the x for the x value, so negative 3, the opposite sign. For the y value, the opposite sign of negative 2. And the radius squared is 25. So if the radius squared is 25, the radius is the square root of that, or 5. We can now graph that. If I were to sketch it really quickly, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. We're going to need a little bit here. So the idea, and that's another video if you forgot how to graph or haven't learned, we graph our center, negative 3, 2, and then we go 5 all the way around. So 1, 2, 3, we go 5 to the right, 5 up, 5 to the left, I'm just estimating, and 5 down, and we can start to sketch it. So if you forgot how to do the graphing of a standard equation, then go ahead and look at the video that I've made for that. So let's try to apply these things to one of these problems. You'll notice here that y squared is on the right side, so we're going to have to move it over to the left by adding or doing the opposite of the sign to both sides. So I'm going to add y squared to both sides. And that cancels out. So what I really have at this point is, and I'm going to reorder it so I have x squared right here, plus 8x right here, leave a little space, and then y squared, which is right here, minus 2y, which is right here, equals 64. So to complete this, I am going to follow the steps we just talked about. The first step is going to be to take half of this number here and square it in a perfect square. By doing this, we're adding 4 squared to this side, and we're going to add to this side as well, 16. The same thing here, I'm going to take half of this number. Half of 2 is negative 1, and negative 1 squared is 1, so I'm going to add 1 to this side. So when I finish completing my square, I have a plus in between them, and then I have 60, 70, 81. We can even graph this now. The center is going to be at negative 4, 1, opposite of 4, opposite of negative 1, we change the signs. And the radius squared is 81. So to get the radius, we square root it and get 9. Let's do one more. Here we have x squared plus 2x. So that's in the correct order. We need to move over the negative, or move the 10y by subtracting negative 10y on both sides. So to organize, I have x squared plus 2x, I'll leave a space, we're going to add here something, plus y squared minus 10y, and a little space, equals 55. So the next step is to get half of the middle term. So half of 2 is 1. And so the number here is 1 squared. If I really need to FOIL, I could, again to remind you, when we multiply this out, we get x squared, x times x, plus 1x, plus another 1x, and then 1 times 1 is 1. So that's why when we're going backwards, when we since we have two of these, we divide it by half in the middle term, because these are the middle term. And the reason we just look at this and say square the 1 is because we know at the end the 1 and the 1 is going to multiply itself. So the number we're adding to both sides then would be 1. And by doing that, I need to add it to this side. And I'll do the same thing here. I'll divide by 2, and then I'll square it. Y minus 5 squared. And so 5 squared is 25, and I'm going to add it here to this side. So I now have my standard form. I just need to add this. It's going to be 81 again, coincidentally. So my center will be negative 1, 5, and my radius will be square root of 81, or 9. So if you understand this, great job. I mean, this is pretty complicated. You can give yourself a pat on the back because you've gone from basic algebra to slightly more advanced algebra. And I remember doing this in school and feeling pretty smart that we could understand how to manipulate all of this and even solve things. I hope this helps, and let me know if you have any questions. Take care.